Hello and welcome to another episode of Mr. Walker's Chemistry. Today we're going to be talking about isotopes, and I hope that in just a few minutes you'll realize why I called this weightlifting. So let's take a quick second here and review kind of what we've already learned. Okay. So let's start with the atom. We've learned that the atom has had many iterations in history of the atom, starting way back in the Greek time when people thought that, stuff, being matter, was made up of something called an atom, all right, and that it was indivisible. And then we later learned in the 18th and 19th centuries that the atom is in fact divisible, meaning we can break it into smaller things, and inside of that are protons, neutrons, and electrons, and that each type of atom has a different number of these subatomic particles. For example, helium has 2 protons, whereas carbon has 6 protons, and then the neutrons and electrons will vary. In a previous video I talked about how electrons will vary, and we call that an ion, and electrons affect the charge because they are negative. Well, today we're going to be talking about the neutrons in isotopes. So this is where that weightlifting thing comes in. Okay, so by the end of this video you should know what an isotope is. Alright, if you go home and someone asks you what is an isotope, you should be able to tell them, your own definition of what an isotope is. And you should be able to calculate the number of neutrons and calculate the mass given certain pieces of information. So we'll do some examples with that, and you'll have some practice problems at the end and in the review. Alright, so simply start out with the definition. An isotope. What is an isotope? Alright, isotopes are atoms with a total mass different from one that's on the periodic table. Alright, so for example, carbon, which you can see here, has a mass of about 12. Okay, so mass of about 12, it has 6 protons, and this one is neutral, so it comes with 6 electrons as well to balance out the protons. Alright, but this is not all that can happen. I mean, this atomic number here, as you can see, it's not exactly 12. It's 12.01. And that's because this mass is an average of all the different varieties of carbon that you can find. And we call these different varieties isotopes. So I've got this other graphic up here, which I hope will help explain some things. Alright, so let's blow this up a little bit and bring it all the way to the front. Alright, so we've got 2 different carbon atoms here. We've got a carbon with a mass of 12 and a carbon with a mass of 14. And you can see here when you name them carbon 12 or carbon 14. And for the most part, all of your carbons are going to be of this type here, the carbon 12. And this is completely harmless carbon. It's the stuff that's found in the graphite of your pencil, it's the stuff that's in diamonds, all that sort of stuff. It's very, very safe, and it's everywhere. Okay, but we can change this. We can change this by, as you can see here, we're going to change the number of neutrons. And this number of neutrons, of course, changes the mass, because protons plus neutrons, protons plus neutrons equals mass. Learned that way back when. Okay, so protons and neutrons are mass, so 6 plus 6 is 12, simple enough, and 6 plus 8 is 14. So then we have these different isotopes that exist because of the different numbers of neutrons. So carbon 12 safe. Carbon 14, interesting fact, is actually radioactive, and that is not one that you really want to mess with too much. That's actually very harmful. They use carbon 14 in certain things. Not so much X-rays anymore, but I think they used to use them in X-rays and all sorts of other stuff. They're pretty neat. Okay, so there are all types of different isotopes. As you can see, there's carbon 11, carbon 13, and carbon 14, and then carbon 12 is your normal one. So if you're looking for an isotope, you should look for one that has a different number than the one that is primarily on the periodic table, of course rounded up or down as accordingly. So why do carbon atoms have different masses? Well, I think we've just covered this, okay? So make sure that you can answer this question. Why do carbon atoms have different masses? So, this is another good question to think about. If they're all carbon, do the protons change? All right. This graphic on the previous slide might help you, okay? If they're all carbon, do the protons change? And that's a yes or no answer. I think that you can answer that pretty easily. Okay. So do be able to answer these questions. Come back to this part later if you need to. All right. So we know number of neutrons is changing. We've got this same diagram here again. And this happens naturally. These isotopes are found throughout the universe. There are man-made isotopes of different things, but usually we're going to be talking about ones that are just naturally found, naturally occurring isotopes. And every single element has one. Okay, so how do we know if we have an isotope? Well, okay, we do some simple calculation. So for example, you see this. We've got an oxygen atom. We know that by the O. O is the symbol for oxygen, with a mass of 17. We've got 8 as the atomic number, so 8 protons, and a -2 charge. So we know we have 10 electrons, because we have 2 more electrons than we have protons. All right, and remember this little image here, okay? Mass in the top corner, atomic number / protons in the bottom corner, charge up here, and if there were a subscript, it would go there, but we don't have one, so there's only one oxygen atom in this case. So what does it all mean? All right. We know that both protons and neutrons contribute to the mass. So let's highlight that. Okay, protons and neutrons contribute to the mass. Simple enough. So mathematically, protons plus neutrons equal mass. Very simple. So using this symbol, we can find all of these values. So if I were to use this example here, we're going to use this information. Okay, charge is irrelevant when I'm looking at isotopes because the charge is for the other subatomic particle that we're not talking about here, which would be electrons. Alright, so let's pull it out. Let's pull out some information. So we know we have 8 protons. So I'll put the symbol here for protons, P+. Okay, and we do not know how many electrons we have. So we're going to put an X for for neutrons, I'm sorry. And that's going to equal our mass, which in this case is 17. So 8 plus X equals 17. We can solve that very quickly, and we find that we have 9 equals X. So we have 9 neutrons. We use the little symbol here for neutrons, which is an N with a 0 for 0 charge. Okay, so we have 9 neutrons. Very, very simple. Alright, so more example problems. Let's try some words problems here. I'm just going to do one, and then you guys try and do the other 2, okay? You find an element with 12 protons. Okay, so we know we've got 12 of those. 12 neutrons. Okay, number 1, what's the mass? Okay, 12 protons, 12 neutrons. What is the mass? Well, that's simple. 12 plus 12 equals 24. So we have a mass of 24. All right. Here's another one. You find a carbon atom. Carbon is important, with a mass of 13. How many neutrons does it have? All right, well, carbon, how many protons does carbon have? Go look and find it, okay? I've got a periodic table here. I recommend that you pull out your periodic table and start using it. All right, so if we pull up our periodic table here big enough to see, hopefully that's big enough, carbon has 6 as the atomic number, and it weighs 13, so how many neutrons? I think you should be able to figure that out. Okay, if not, ask about it. And then another one, you find an element with 15 protons, 11 neutrons. What's the mass? That's very similar to number 1. How about some symbol-based problems? All right, for each of these, find the number of neutrons. I'll do the first one. Okay, we've got a calcium with a mass of 40. Okay, so that's mass. We've got number 20, that's protons. It has a charge of 2, but remember we don't care about charge because that has to do with electrons. Alright, so we need to find the number of neutrons, mass and protons. Alright, so we have 20 protons. Let me type since I can't seem to be writing today. 20 protons, so P plus, okay, plus the number of neutrons, N0, is going to equal our mass, which is, in this case, 40 AMU. So when we solve that, 20 plus 20 equals 40. Alright, so try the rest of these. You've got a carbon with a mass of 12, 6 protons, find the neutrons, and so on. Okay? Here's some practice for you. Alright, here's a good chance to pause the video and solve these. Alright, so for each problem, use the periodic table to determine if the element is an isotope or normal. Alright, and then also, not only that, you need to answer each problem. So, for example, for problem 1, we have an element with 4 protons, 4 neutrons. What's the mass? Okay, so find the mass. Then tell me if this element that has atomic number 4 with a mass of whatever you find the mass to be is actually an isotope or normal. Okay, so you have to look on the periodic table and compare your answer to what's on the periodic table to figure that out. Same thing down here. Alright, you've got lithium, find the number of neutrons, find the number of neutrons for iodine, hydrogen, etc. And then tell me if it's an isotope or not. So for review, what are isotopes? What's the formula for finding mass? And what are the different parts of this symbol? So in class, I expect you to be able to calculate the various things that you have in the practice here, to define what an isotope is, and to tell me what the formula is for finding mass, and use this symbol to find either protons, neutrons, or electrons. Alright, so that wraps up this unit, and I hope you learned something, and I'll see you next time.